Hello students, in this video let us discuss one question that is related to the chromatography. That question is also from January JEE main question. So the question is a chromatography column packed with silica gel as a stationary phase was used to separate mixture of compounds consisting of A. benzylamide, B. aniline and C. acetophenone. When the column is eluted with a mixture of solvents hexane and ethyl acetate 20 and 80 ratio, the sequence of compounds obtained. So here in this case, the column is filled with silica gel. It is a stationary phase. Okay. So column chromatography contains two phases, stationary phase and moving phase. Here the hexane and ethyl acetate, this solvent is a moving phase. It is a moving phase. So now here silica gel, here mixture of compounds A plus B plus C. Here A is a benzylamide, B is a aniline and C is a acetophenone. So now in this case, so actually here it is a mixture of the, that means hexane and ethyl acetate. This hexane is completely non-polar. That non-polar solvent percentage is very less, 20%, and ethyl acetate, it means it is a slightly polar. Here partial negative, here partial positive, here partial negative. So it is a polar solvent. It is a polar solvent. Okay. So in this case here, that mixture has a more polar nature finally. So here this chromatography separation, that means using solvent, here it depends on the just like one principle, like dissolve like. Okay, like dissolve like principle. That means here the polar compounds are more soluble in polar solvents and non-polar compounds are soluble in non-polar solvents. So here higher the polarity for a compound, that compound is soluble in polar solvent. Now here for given compounds it is a dipole moment order. The benzylamide 2.71, aniline 1.59, acetophenone 3.05. So which one has a higher polarity? So polarity is directly proportional to dipole moment. That means here acetophenone C and next benzylamide A and next B and least polarity aniline. So which is the more polar compound? Acetophenone is the more polar compound. So now in this case, it is a silica gel stationary phase, it is a mixture of compound, it is a moving phase. Okay. So whenever open this top cork, here solvent is moving. Okay. So along with solvent, here that means here that solvent is moving through the mixture of compounds A plus B plus C. When the solvent is coming down, along with the solvent, which compound comes first of all? That means here it is a polar solvent mixture. That means here 80% ethyl acetate is present. That means in excess quantity. So here this mixture has a more polar nature. So with moving of this solvent, here compound C is moving first of all, because the more polar compound dissolve in more polar solvent. Okay, so that means here like dissolve like, here compound C more polar compound, so that is moving with solvent. So here we will get the compound C first one. So next polarity 2.71, that means here benzylamide, so here compound A, and least polarity and B, that slowly moves because first more polar compound is moving with more polar solvent. So here order of compounds obtained, C greater than C first and next A and next and finally B compound. So that means here by adding excess of the solvent we can get this fraction. Okay, so that means here we will get first fraction of compound C and next fraction of compound A and next fraction of compound B. So that means sequence of compounds obtained in this chromatography, that means separation techniques, C first of all and next A and then B. Okay, for suppose in this case here 100% of hexane is used. Okay, if 100% of hexane is used as a solvent, then the sequence of compounds obtained, it is a non-polar solvent. Okay, it is a non-polar solvent. So in with non-polar solvents, for example, if it is a non-polar solvent, that is a hexane, with non-polar solvent, here less polar compounds are moving first of all. That means a less polar compound B first is moving. Okay, and next A benzyl and next C, the reverse in case. Okay, if non-polar solvent is used 100%, so non-polar solvent is the hexane. So here non-polar compound, that means a less polar compounds are moving with non-polar solvent. Here in this case it is ethyl acetate 80%, that is a polar solvent. So with this polar solvent more polar compounds are moving first. Okay, so like ethyl acetate, here CH3C triple bond N methyl cyanide, that means a ethane nitrile, that also used as a solvent. Okay, this is also polar solvent because of the alkyl difference between carbon and nitrogen, that has a polar nature. Okay, so as a non-polar solvents we can use hexane or cyclohexane or CCl4. That's it. Okay, so that is a separation technique of the that means uh, chromatography. So actually the chromatography can be used for the identification of the number of compounds in a given mixture. For suppose if it is a mixture of some compounds. Okay, so after completion of this column chromatography column, here we can get the three bands. Here indication of three bands, the appearance of the three bands, we can conclude that that mixture contains three compounds. Okay, so this chromatography technique can be used for the identification of number of compounds which are present in a given mixture. Okay, if we obtain four bands, that means here that mixture contains four compounds. Okay, thank you for watching. Please subscribe my channel.